See here, this is for uniform motion. For non-uniform motion, it can go like a parabola. Okay, this kind of it will go. So this is mentioned here as non-uniform motion. Speed time graph, velocity speed here mentioned in the same sense. Okay, so here the graph, velocity time graph, what they said, suppose if you are going 40 kilometer per hour speed, you are going with the same speed. Okay, you are not changing your speed or velocity, you are going in a straight direction, constantly you are maintaining your speed. Okay, that means first 1 hour you will cover. See here, first 1 hour, just a minute, I'll erase this one. See, look at here, for the first 1 hour. Okay, for first 1 hour, see here, for first 1 hour. Okay, the first 1 hour, it can cover 40, it will go 40 kilometer per hour speed. The next 1 hour also it can cover 40 kilometer per hour speed, and here also 40 kilometer. So next third hour also you covered 40 kilometer per hour speed, next also you cover 40 kilometer per hour speed. That means you are going in a same speed. So if we join that all points, if we join that all points, so what you are getting? So you are getting one straight line, that is called constant speed. Okay, constant speed, that means constant speed is nothing but you are not changing your speed. So if you are going in the constant speed means what will be your acceleration? So acceleration is nothing but changing your velocity with respect to time. So acceleration equal to, so changing your velocity. What is your velocity? If you are, what is your speed? The final speed, here I mentioned v. Okay, v means you are going in the final speed v. Okay, initial speed, here I mentioned u. Okay, so here I mentioned u divided by time. So this is called your acceleration. So here, are you changing any speed? Here you are going 40 kilometer per hour in the same speed. Okay, for example, if you are going in the bike, suddenly you are changing your speed, no, by using that accelerator. So you are changing your speed. So when if you are not changing your speed means you are going in the same speed, that means there is no acceleration is drifted. Okay, so that means no acceleration is possible. So if you are going in the same speed, what will happen? Your final velocity and the initial velocity should be here becomes to 0, because what will happen, final speed here it will not be changed. Okay, you are going in the same speed. So initial speed also 40, initial speed also 40, final speed also 40, 40 minus 40 0, so 0 by anything. So acceleration in this case is 0. So 0 meter by second square. Okay, so acceleration is here 0. Okay, so can you understand? So what I'm saying, so if you are going in the constant speed, acceleration is 0. Okay, but how much distance we can cover from the speed time graph? Okay, or velocity time graph. So velocity equal to displacement divided by time, as you know. So velocity, see here, velocity equal to, velocity equal to displacement divided by time. Yes. Okay, so displacement or distance, if you want to find means displacement, which is equal to velocity into time. So velocity into time. Okay. So in this manner, we can find that how much distance or displacement can be covered in that speed or velocity time graph. Okay. So from the velocity time graph, what we can understand, we can find the distance or displacement easily. Okay. So the next here, okay, from here I'll say that for uniformly accelerated. What is meant by uniformly accelerated? For that, what we have to do? See here, here I mentioned some data. Okay, so based on this, if you drawing the graph based on this data, so we can cover whether it's a uniformly accelerated or non-uniformly accelerated. Okay, the first one, uniformly accelerated motion. Okay, in the velocity time graph, see here in the velocity time graph, we can find whether it is a uniform acceleration or non-uniform acceleration. Okay, in the velocity time graph, for example, see here, here in the point A, here in the point A, the starting point, okay, and here mention the point E, okay, this is your final point. Okay, from A to E, when object going at uniform acceleration, that means it can change its speed or velocity uniformly with respect to time. Then if we plot the graph, the data will come in a straight line. Okay, so if I want to find how much acceleration, okay, because it is a uniform acceleration motion, no, so how much acceleration if it possible means, so just from the point E, just draw the perpendicular line which joins that x-axis. Okay, okay, so this is a perpendicular line. So next one here from A, join that perpendicular line, draw one perpendicular line, and from the point E, draw the the line which is intersect with the y-axis. Okay, now can you find that slope of this line? For example, A to E. Okay, in the mathematics we can find the slope formula. Slope is nothing but here, so m, which is equal to, in your higher class you will study that slope is nothing but how much slanting line, okay, slanting. So slope equal to m, which is equal to y2 minus y1 divided by x2 minus x1. So it is nothing but in the y-axis from here, okay, in the y-axis, what is the total difference? Okay, from A to E, from A to E, see here, so this is the y, okay, here in this point. See here, this one. So this one I will mention here, okay. So from here to here, I will mention y1, okay. So here to here totally, I mentioned y2, okay. From here to here, from the point from here to here, I mentioned x2, here x1. Okay. Now can you say that what is the distance between D to E, DE, this distance? So totally y2 from A to B. Y1 means what is the DC? A, B, DC are same height. That means DC also here same distance. That means this is y1. Okay. So this one y1 means this one y2, that means y2 minus y1, if we subtract means we will get that DE length, okay, the length of that DE. So y2 minus y1, okay. So this one, this length we can find. And what about from AD length? If we know that from point O to C, x2 OB x1 means, so we can find that, so OC minus OB, that is called x2 minus x1, okay. So here I mentioned x is a general notation, but in the x-axis what we have taken? Time. So shall I mention that x2 as t2, x1 as t1? So t2 minus t1 for the x-axis AD or BC, same length. So T2 minus T1. This is T2 minus T1, and DE, which is called velocity here. So V2 minus V1. I take V2 minus V1. So if we put the value V2 minus V1 divided by here T2 minus T1, we will get that acceleration. Okay, what is that? Uniform acceleration. Okay, so the next concept is non-uniform accelerated. For that non-uniform accelerated, see here, so look at the graph. The graph is not going in a straight manner. That means the velocity will not moving, or speed will not be changing in the uniform rate. Okay, it will covered in non-uniform rate. Okay, so for that the graph will not be the straight line. Okay, so here, okay, the first one, see here. So the non-uniform acceleration. So again, I will repeat my graph. Those who cannot understand, please once again, just listen. See here, for uniform speed, what is the graph? The given data I mentioned here. Okay, for that, if we plot the distance, time, distance we have taken as y-axis, time we have taken as x-axis. Just mark the point, join the line. See here, what is your final position? Okay, what is your final position? So just wait a minute, I will rub this one, and here also I will mention. Just wait, how to find that from the distance time graph? What is the use of it? So distance time graph, we can find whether it is uniform speed or not. So it's a uniform speed. From the distance time graph, we can find the speed. Sir, how sir we can find the speed? What is the final point here? What is the final point here? This is your final point. This is your initial point. So for this straight line, we have to find the slope. Slope is nothing but from the x-axis, how much get deviated, slanting. Okay, from the x-axis, how much get deviated, this is slanting. Okay, this is called slope. Okay, if we find the slope of this line, we can find the distance. So whenever, if it is going in a uniform or straight here, this is your, what is that axis? This is the y-axis. So y-axis we have taken as distance. So distance, how much distance it can cover? Just draw the line. Draw the line here. Okay, and just draw the line here. Connect with the axis. So this one, right? So this one, your y-axis. Okay, y-axis, what we have taken? Distance, right? So y-axis you have taken as distance. So in the x-axis here, this one, what is that length? This is time, right? So distance, if distance, this length and this length will be equal. So if you take the ratio distance divided by time, okay, so we can call it as speed, right? So from the given graph, distance time graph, we can find the how much speed it is going. Okay, so the next one, for non-uniform speed, so the given data is this much. Okay, so here, just a minute. So the velocity time graph, same way, if it is going in the constant speed, this much, and for uniformly accelerated, given data this much, same way from A to E, how much acceleration means. So A to E, we have to find the slope. So ED divided by DA. Okay, so if you want to find the distance means, under that this area, this portion from A to E, covered by that full area. If you found means that is we can covered by that. So how much distance it can cover? So how much distance it can cover from A to E? That means if you join that x-axis, if you intersect the points along with the y-axis, so the area enclosed by the figure, if we found means we can find the distance from A to E. So area found that area bound that ADE, from that we can find that the acceleration. Okay. So non-uniform acceleration, it will not be in the straight manner. So unequal, it is not going in the uniform rate. Okay. So yes, students. So this is the today's session. Just to read the book once again. So what are the concept I said? First listen and then read. And if you have any doubts, so we can meet with that Zoom ID. Okay, that Zoom app, I will meet and I will resolve your doubt. So thank you all. Thank you.